Okay, let's tackle percentages. We're going to master everything from the basics to some tricky real-world problems.
Think about it. Discounts, test scores, even your phone's battery life. What do they all have in common?
Yep, they all run on percentages. And by the end of this, you're going to be a pro.
So, first things first, what even is a percent? Let's get down to the absolute basics.
It's actually pretty simple. The word literally means for every 100. It's just a special kind of fraction.
So when you see something like 8%, it just means 8 parts out of 100. That's it.
Okay, time to build your toolkit. These are the core calculations you'll need to master this stuff.
Want to turn a fraction into a percent, like 3 over 5? Just multiply by 100. Boom, 60%.
Now, these two formulas right here, they're your secret weapons. They solve almost any percentage problem. Let's see that first one in action. For 36 is what percent of 144, just divide and multiply. All right, enough theory. Let's solve some real-world problems and see how this actually works.
So here's a classic. A guy spends 65% of his pay. We know he saves $525 a month.
The question is, what's his total salary? We know the part, but how do we find the whole?
Well, if he spends 65%, he must save the other 35%, and that 35% is our $525.
Once you know that, the rest is easy. His total monthly salary is $1,500.
Okay, let's step it up a bit with an election problem. This one's a little trickier. We know the loser share and the margin of defeat. So, how do we find the total number of votes?
Here's the trick. The winner got 57%. The difference between them is 14%. That's your 4,900 votes.
And just like that, you know the total was 35,000 votes. Simple when you break it down, right?
Now for something that trips a lot of people up, what happens with multiple percentage changes?
So is a 20% increase, then an 8% decrease, the same as just a 12% increase? What do you think?
Nope, not even close. You have to calculate that second change on the new total, not the original.
So the actual result is a 10.4% increase. It's a small difference, but it's an absolutely crucial one.
Okay, you've got the tools, you've seen the examples, now it's your turn to solve one.
What's the percentage of good oranges here? Give it a shot and start thinking, what else can you calculate now?